The next periodicity is what? Ionization energy. So we always use what? IE to denote ionization energy. What is ionization energy? It's the minimum amount of energy required to take out 1 mole of electron from the gaseous atom. The minimum amount of energy required to what? To take out what? Or to remove 1 mole of electron from the gaseous what? Atom is called ionization energy. And this ionization energy is an endothermic reaction. What? Endothermic what? Reaction. Assume we have an element X. And I want to what? Remove electron from what? From element X. I need to add what? Ionization energy to what? To it. I.e. the energy required to take out electron from what? From this element X. If we now take what? 1 mole of electron here from it, this S will become positive. So the energy required here that we added to remove, to take out this electron from what? From this S to become ion is called ionization energy. Assume that what? And this one, to take first electron, we call it what? This ionization energy is simple. The energy required to take out what? 1 mole of electron from the gaseous atom is called ionization energy. Take for instance, assume we have what? Sodium. See, we have sodium, atomic number 11, plus ionization what? Energy to give us what? Sodium Na plus this. That take out what? 1 mole of electron from the what? From this sodium atom. That was ionization energy. But in the case of what? Of magnesium, which is atomic number 12, we have ionization energy. The energy that is what? Remove the electron out from it. You now have what? Magnesium Mg plus 1 mole of electron. The energy here that take out what? First electron out from magnesium, you call this one what? First ionization energy. So you will now take what? This magnesium ion again, Mg plus atomic number 12 plus second what? Ionization energy to give you what? Mg. This we have 2. So in magnesium, we have how many ionization energy there? 2. In sodium, how many ionization energy? 3. So the energy required to take out electron from sodium is less than what? The energy required to take out electron what? From magnesium. That's ionization energy. Because in magnesium we have what? 2 ionization energy. But if we are talking about what? Aluminium, Al, atomic number 13. So here now, we need what? 3 ionization energy before we can have aluminium 3 plus. So the energy, ionization energy required in what? In sodium, less than magnesium, less than what? Less than aluminium. If you observe that what? The 3 of them can be what? They are in group what? Period 3. Abi, what are the factors that are affecting ionization energy? Number 1, factors affecting ionization what? Energy, we have nuclear charge. Number 2, we have atomic radius. Number 3, we have screening effects. Inner screening effects. What is nuclear charge? We all know that what nuclear charge is the number of proton in the what? In the nucleus of an atom. And the nuclear charge is directly proportional to what? To ionization energy. That is, the increase in nuclear charge increase in what? Ionization energy. Look at it here. The nuclear charge is increased across the period. Here is 3, is 4, 5, 6, 7, is increased like this, Abi. So as the nuclear charge is increased across the period, the ionization energy is also what? Also increase. That's the relationship between ionization energy and what? And nuclear charge. Increase in nuclear charge is what? Increase in what? In ionization energy. Increase in atomic number is the what? Increase in what? Ionization energy. The next one is what? Atomic radii. The atomic radii is what? Is inversely proportional to ionization energy. Atomic radii of any element is inversely about to the what? To the ionization energy. That is, increase in what? Atomic radii lead to the what? Decrease in ionization energy. This is proportional symbol. Atomic radii is inversely about to the what? Ionization energy. That is, when atomic energy is what? Is increased, the energy will be what? Reduced. So let us look at it now. The atomic radii is decreased across the period. Abi, when it's decreased across the period, the ionization energy will increase across the period. So the atomic radius is increased down the group. Therefore, ionization energy is what? Decreased down the what? Down the group. But this inner screening effect is also what? Affect ionization energy. So the effect of what? Of screening effect. Look at the screening effect. The screening effect has what? It has no effect on periods. It has what? No effect on the period of what? An element, because they have the same number of what? Of shell. But the screening effect has effect on what? On a group of what? Group of an element. Let's take group 1 as case of study: lithium, sodium, potassium. This one has what? 2, 1, 2, 8, 1, 2, 8, 9. Sorry, 2, 8, 1. The screening effect here is what? Is increased down the group. As a result of that, the screening effect increased down the group. As a result of that, the ionization energy will decrease down the group. Screening effect in group is what? Is decrease down the group. Sorry, it's increased down the group. Screening effect increase down the what? The group. Screening effect increase down the group, and it now lead to the what? Make ionization energy to what? To decrease down the what? The group. Down the group, the screening effect is what? Is increase. While ionization energy is what? Is decrease down what? Down the group. That's all about what? Ionization. And the next thing now is what? The variation of ionization energy across the what? Across the group, across the period, and down the group. So the ionization energy across the what? Across the period is increased as the nuclear energy is what? Is increased. So if you have what? Sodium, magnesium, and aluminium, and what? Silicon, phosphorus, they are the same period. Which of them is what? Has what? Ionization energy. Higher ionization energy. As the number 11, 12, 13, 14, 15, as this number atomic is increased, the ionization energy is also what? Increase. But down the what? The group, sodium and potassium, the ionization energy will decrease down the what? The group. But increase across the what? Across the period. That's all what? About what? Ionization energy.